16 says find x. Now, they don't give us the arc it intercepts, but they give us this one as 56. I can also see that I have a semicircle here. So basically a semicircle has 180 degrees. If I subtract from it 56, what's left over is 124. So this unmarked arc is 124 degrees. Angle x is half the arc. Half of 124 is 62. So x would be 62. Because that is an angle, I'm going to call it 62 degrees. 17 wants three things. It wants angle Q. It wants arc PQ. And it wants arc QSR. Well, angle Q intercepts this arc here, which is 120 degrees. So measure of angle Q is half of the arc, or 60 degrees. So this is 60. And then it wants arc PQ. Well, you can find that two ways. You can use this triangle to realize that this is 30 and then double 30 to get arc PQ. Or you could have said from R to P to Q is a semicircle, of which we have 120 already, 180 minus 120. Either way, you get arc PQ's measure to be 60 degrees. So there's a couple ways we can go about looking at that. And then for arc QSR is a semicircle. So semicircles measure are 180 degrees. 8 wants to find measure of angle D. Notice D intercepts arc AC, which B also intercepts. So D is simply going to be 27 degrees. If two arcs intercept the same, two angles intercept the same arc, they are congruent. Oh, you could have found AC by doubling 27 and called it 54, and then taken half of 54 to get to D, or you could just recognize that they have to be the same. Now 19 is a little bit different. It wants angle POQ, that one. Now notice POQ is a central angle, but I'm going to use arc or angle PRQ to find it. Now PRQ has its vertex on the circle, which means it's an inscribed angle, and the angle is half the arc. So the angle being 62, 62 is half of arc PQ. Arc PQ would be 124 degrees. And then if you remember from a number of lessons ago, a central angle is actually equal to the arc it intercepts. So measure of angle POQ is equal to 124 degrees.